Hey, quick question. What do Netflix, Instagram, and NASA have in common? They all run on Python. And here's the wild part. Python is one of the easiest programming languages to learn. Like, genuinely. You can write your first working program in under 10 minutes. So whether you want to build websites, crunch data, automate boring tasks, or just finally understand what all the programmer hype is about, you're in exactly the right place. Let's do this. Here's what we're covering today. We're going to start with the absolute basics: what Python is, why it's so popular, and how it actually works. Then we'll walk through the core building blocks: variables, data types, conditionals, loops, and functions. After that, we'll look at some real, practical examples, the kind of code you'd actually write in the real world. By the end of this video, you'll understand how Python thinks. You'll be able to read a block of Python code and actually know what's happening. And you'll have a solid foundation to start building from. No experience required. I'm going to assume you've maybe heard of programming, but haven't done much of it. If you have some background, great. You'll fly through the early stuff. All right, let's start from the very beginning. So, what actually is Python? Python is a programming language. But here's a better way to think about it. It's a way of giving instructions to a computer in something that almost looks like plain English. Compare that to older languages like C++ or Java, which look more like alien math homework. And you can see why Python exploded in popularity. Here's a classic example. If you want to print the words "Hello World" in a few different languages, it looks like this. In Java, you'd write the whole text in the blue box. In Python, you just write print "Hello World." That's it. One line, done. Python was created in 1991 by a Dutch programmer named Guido van Rossum. The name, by the way, isn't from the snake. It's from Monty Python, the British comedy group, which tells you a lot about the vibe of the language. It was designed to be fun, readable, and practical. Today, Python is consistently ranked as the #1 or #2 most popular programming language in the world. It runs on virtually every operating system, and there are thousands of free libraries, pre-built tools that you can plug into your code to do almost anything. One more thing before we move on. Python is an interpreted language. What does that mean? Think of it like this. Some languages, like C, are like a book that gets fully translated before anyone reads it. Python is more like a live translator. You hand it one line of code, it runs it immediately, and moves to the next line. This makes it super fast to write and test code. Before you can write a single line of Python, you need to get it installed on your machine. The good news? It only takes a few minutes, and you only ever have to do it once. Step 1. Download Python. Head to python.org/downloads. The site will automatically detect your operating system, whether you're on Windows, Mac OS, or Linux, and recommend the latest stable version. Go ahead and click that download button. Step 2. Run the installer. Once the installer downloads, open it. You'll see a setup screen. And here's the one thing you absolutely cannot skip. Check the box that says Add Python to Path. It's usually at the bottom of the first screen. If you miss this, Python won't be recognized in your terminal, and you'll have to reinstall. Once that's checked, click Install Now and let it run. Step 3. Verify the installation. When it's done, open your terminal. That's Command Prompt on Windows or Terminal on Mac OS and Linux. And type Python --version. If you see a version number printed back at you, you're all set. Python is installed and ready to go. Now that Python is installed, let's actually run some code. There are two main ways to do this, and knowing when to use each one will save you a lot of time. The first is the interactive interpreter, sometimes called the CLI or the REPL. To launch it, open your terminal and type Python, or Python 3 on some systems. You'll see a prompt with 3 arrows, as shown. That means Python is running and waiting for you. From here, you can type code directly, and it executes immediately. So if you type print hello Python and hit enter, you'll see the output right away. You can set variables, do math, try out a function, anything you want to test on the fly. When you're done, just type exit to close it. The interpreter is great for quick experiments, but for anything bigger, you'll want a proper code editor or IDE. These tools give you features like auto-completion, syntax highlighting, and built-in debugging, things that make writing and managing larger programs much easier. The most popular options are VS Code, which is free and incredibly flexible, PyCharm, which is built specifically for Python, and Jupyter Notebooks, which are especially popular in data science. Any of these will serve you well. Pick whichever feels comfortable to start. As a beginner, I'd recommend starting with the interpreter to get a feel for the language, then moving to VS Code once your programs start growing. Okay, let's write some actual code. The first thing you need to understand is variables. A variable is just a named container for storing information. Think of it like a labeled box. You put something in the box, give it a label, and then whenever you need that thing, you just call its name. Here's how you create a variable in Python. Name equals, quote, Alex, quote. Age equals 28. Height equals 5.9. See how natural that reads? Name equals Alex. Age equals 28. It's almost like writing notes. Now, those 3 variables each hold a different type of data. This is important. Python has several data types, and they behave differently. Strings, that's text. Anything wrapped in quotes. Greeting equals hello, world. Think of a string like a strand of characters, letters, spaces, punctuation, strung together like beads on a necklace. Integers are whole numbers, no decimal. Score equals 100. Year equals 2024. Floats, numbers with a decimal point. Temperature equals 98.6. Price equals 4.99. Booleans. This one's interesting. A Boolean can only be one of 2 things, true or false. Capital T, capital F, is underscore logged underscore in equals true. Has premium equals false. Booleans are like light switches, on or off, yes or no, and they show up constantly in programming logic. We'll see why in a minute. Now here's something cool about Python. It figures out the data type automatically. You don't have to tell it, hey, this is a string, or hey, this is an integer. It just looks at the value and knows. This is called dynamic typing, and it's one of the things that makes Python so beginner-friendly. One last thing on variables. Python has a built-in function called type that tells you what kind of data something is. Super useful when you're debugging and something isn't behaving the way you expect. So far, we've stored single pieces of data. But what if you need to store a collection of things, like a list of names or a set of scores? That's where lists come in. A list in Python is exactly what it sounds like. An ordered collection of items. Fruits equals apple, banana, cherry. Scores equals 95, 87, 72, 100. You create a list with square brackets and separate items with commas. The items can be any data type: strings, numbers, even other lists. You access items in a list by their index, their position. And here's a quirk that trips up almost every beginner. Python starts counting at 0, not 1. Fruits equals apple, banana, cherry. Print fruits 0. Output apple. Print fruits 1. Output banana. Print fruits 2. Output cherry. Think of it like floors in a European building. The ground floor is floor 0. Once you internalize that, it becomes second nature. Lists are also mutable, meaning you can change them after creating them. Add things, remove things, reorder things. Fruits.append, mango adds mango to the end. Fruits.remove. Banana removes banana. Print len fruits prints the number of items. Len stands for length. Now, what if you want to store labeled data? Not just a list of values, but key-value pairs. Like a mini database? That's what a dictionary does. Person equals name. Alex, age, 28, city, Toronto. A dictionary uses curly braces. Each entry has a key, like name, and a value, like Alex. You separate them with a colon. To access a value, you use its key. Think of a dictionary like, well, an actual dictionary. You look up a word, the key, to get its definition, the value. Or think of it like a contact card. You ask for the phone number, and it gives you the number associated with that name. Dictionaries are incredibly powerful. A lot of real-world data comes in dictionary format, including JSON, which is basically the language of the Internet. Okay, now things start to get interesting. Because so far, our code just runs, line by line, top to bottom. But real programs need to make decisions. That's where conditionals come in. The if, elif, and else statements. Here's the basic idea in the highlighted box. Read that out loud. If temperature is greater than 90, print this. Else, if temperature is greater than 70, print this. Otherwise, print this. It sounds like English because it basically is English. A few things to notice here. First, the colon at the end of each condition. That's Python's way of saying what follows belongs to this block. Second, the indentation. See how the print lines are pushed in a bit? That indentation is not optional in Python. It's how Python knows which code belongs inside the if, which belongs inside the elif, and so on. Most other languages use curly braces for this. Python uses white space. It forces you to write tidy, readable code. Third, the comparison operators. These are the symbols you use to compare values. Greater than, less than, greater than or equal to, less than or equal to, equal to. Note, two equals signs. One equals sign is for assignment, two is for comparison. Conditionals are the decision-making engine of any program. Every time software does something different based on user input, or time of day, or some piece of data, there's an if statement behind it. Here's a question. What if you need to do the same thing 1,000 times? You're not going to write the same line of code 1,000 times. That's where loops save you. Python has two main types of loops: for loops and while loops. A for loop runs a block of code for each item in a collection. Fruits equals apple, banana, cherry. For fruit in fruits, colon print fruit. Output, apple, banana, cherry. That's it. Python goes through the list, grabs each item one at a time, calls it fruit, and runs the code inside the loop. Clean, simple, readable. You can also loop a specific number of times using the range function. For I in range 5, print I, output 0, 1, 2, 3, 4. Range of 5 gives you 0 through 4. Remember, Python starts at 0. This is great when you need to repeat something a set number of times. Now, a while loop is a little different. Instead of looping through a collection, it keeps running as long as a condition is true. Countdown equals 5. While countdown greater than 0. Print countdown, countdown equals countdown minus 1. Print blastoff, output 5, 4, 3, 2, 1. Blastoff! Think of a while loop like a vending machine. It keeps asking, "Do you want more?" until you say no. The key thing to watch out for: make sure your condition eventually becomes false, or your loop will run forever. That's called an infinite loop, and it's one of the classic beginner mistakes. A function is a reusable block of code that you give a name. Instead of writing the same logic over and over, you write it once, as a function, and call it whenever you need it. Here's the syntax. Def greet name. Print hello name. Def is short for define. You're defining the function. Greet is the name you're giving it. Name is a parameter, a piece of input the function expects. To actually use the function, you call it greet Alex. Output, hello Alex. Greet Jordan. Output, hello Jordan. Greet Taylor. Output, hello Taylor. One function, infinite uses. This is the principle of DRY, don't repeat yourself, and it's one of the most important ideas in programming. Functions can also return a value, meaning they calculate something and send the result back to you. Def add AE-B, return A plus B. Result equals add 3, 5. Print result, output 8. The return keyword is what sends the value back. You can then store it in a variable, use it in another calculation, print it, whatever you need. Let's make a slightly more realistic example. Def calculate tip bill amount, tip percent. Tip equals bill amount times tip percent, divided by 100. Return tip. My underscore tip equals calculate underscore tip 60, 20. Print. Your tip is $sign plus ester my underscore tip. Output. Your tip is $12. Notice I used str there. That converts a number to a string so we can stick it together with other text. That process is called type conversion or casting. Functions are the foundation of organized, maintainable code. Once you start building bigger programs, you'll be writing functions constantly. All right, you've got the building blocks. Now let's put them together with some real, practical examples. Let's build something fun. A number guessing game. Let's break this code down because it uses almost everything we just learned. Import random. This brings in a built-in Python library that can generate random numbers. Libraries are like power-ups. You import them, and suddenly you have a whole set of new tools. Random.randint 1, 10 picks a random integer between 1 and 10. Input. This is a built-in function that pauses the program and waits for the user to type something. Whatever they type comes back as a string. We wrap it in int to convert it to a number. Then we've got a while loop running until the guess is correct, and if elif else inside it to give feedback. That's about 15 lines of code and a fully working interactive game. That's the power of Python. Let's say you're a teacher and you've got a list of student scores. You want to find the average, the highest score, and the lowest score. Pause and read through the first block of code. Notice max and min. These are built-in Python functions that find the highest and lowest values in a list automatically. You don't have to write that logic yourself. Now, let's add one more thing. Let's print a message for students who need help. Read the red block of text. That code will use conditional logic to print the student's score with a warning message if the score is less than 75%. We just looped through data, applied logic, and extracted meaningful information. That's basically what data analysis is at its core. Let's build a tiny contact book using a dictionary of dictionaries. Read the first code block. See what we did there? Each value in contacts is itself a dictionary, a nested dictionary. And we wrapped the lookup logic in a function so we can reuse it. If name in contacts is a really useful pattern, it checks whether a key exists in a dictionary before you try to access it. Without that check, asking for a contact that doesn't exist would cause an error. One more quick one. A function that converts between Celsius and Fahrenheit. Read the temperature converter code. Notice round. Another built-in function. It rounds a number to a specified number of decimal places. In this case, 2 decimal places. Clean, reusable, readable. This is what good Python code looks like. Okay, let's bring it all together. Here's what you learned today. Python is a readable, beginner-friendly programming language used everywhere from web development to data science to AI. It runs line by line and figures out data types automatically. Variables are named containers for storing data. Data types tell Python what kind of data it's working with. Strings, integers, floats, booleans. Lists store ordered collections of items. Dictionaries store key-value pairs, perfect for structured data. Conditionals, if, elif, else. Let your code make decisions based on logic. Loops, for and while. Let your code repeat actions efficiently without copy-pasting. Functions are reusable blocks of code you define once and call whenever you need them. They can take inputs, parameters, and return outputs. And through the examples, we saw how these pieces fit together into real programs: a game, a data analyzer, a contact book, a converter. If you want to keep building, here's what I'd suggest tackling next. Python built-in libraries. Math, datetime, random, OS. There's so much already built in for you. File handling, reading from and writing to files. Incredibly useful. Object-oriented programming, classes and objects. This is where Python really opens up. Popular third-party libraries, pandas for data, requests for the web, Flask for building web apps. The best way to learn is to build something. Pick a small project, anything, and try to build it. You'll hit walls. Google them, break things, fix them. That's the whole process. If this video helped you, drop a like. It genuinely helps the channel and tells me to make more content like this. Subscribe if you're new, because we've got a whole series coming on Python. Leave a comment below. What do you want to build with Python? I read every single one. I'll see you in the next one.